Alright, today we are talking about quadratic functions. This is our new chapter that we're dealing with here in our Algebra 2 class. Specifically, this section is dealing with graphing quadratic functions, and we're going to talk about a few different methods that we have for graphing them. Now, when we talk about quadratic functions, up to this point we talk mostly about linear functions, where those were something that looked like y equals x, and maybe something was multiplied by x, or subtracted or added to x, but ultimately is y equals x, while quadratic functions deal one way or another with y equals x squared. So our parent function, you would say, is y equals x squared. That's this right here. The graph is a U-shaped graph. We call it a parabola. So that's this shape that we see right here. This is a parabola. Other significant things to take note of when we're graphing quadratics: the lowest or highest point is called the vertex, and that is either the minimum. So this right here, this would be our vertex of our graph, this bottom point. We also sometimes call it the minimum or the maximum, depending on how it's oriented. So right now this would be called the minimum. And then also, the vertex always lies on this special line that actually isn't part of the graph, but this is called the axis of symmetry, this red line right here. That's our axis of symmetry. And the axis of symmetry, if you recall, when something is symmetric, means it's the same on both sides. So for example, we have this coordinate here, -1, 1, which means we also have the coordinate 1, 1 on here. In a similar manner, we have the coordinate -2, 4 on here, and then on the other side we have the coordinate 2, 4. So that is how those how that axis of symmetry works. If you take a look, any graph you can graph by making an xy chart. So for example, if I take -2, plug it into my function, -2 squared, that's -2 times -2 is 4. -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Now this is a very simple example. They do get a little bit more complex. So doing this, pick an x value and see what y value comes out, doesn't always work very nicely. It'll work every time. Every time you pick an x value, plug it in, you will get a y out. But there are more efficient ways of doing this, and that's what we're going to talk about in this video. So the first one that we're going to talk about is graphing in standard form. So this looks like this: y equals ax squared plus bx plus c. This is the form that we typically see equations in. There are a couple of other forms to talk about. We'll use this probably at least 80% of the time. A little bit of characteristics of this. A tells us if the parabola opens up or down, or if it's wide or narrow, and we'll get into that in a little bit. C, that's the C value, and this is the y-intercept, and that makes sense. And that's when x equals 0. Think about this. So remember, the y-intercept, any y-intercept, is when the x value is 0. We haven't gone left or right at all. So if x is 0 for this part, a times 0 squared is 0, plus b times 0 is 0, plus c. So when 0 goes in for x, we just get that c out. So 0 goes in, that's on our y-intercept, c comes out. We find our axis of symmetry at, it's an x value, and that's at -b over 2a. And as I said before, the vertex is always on the axis of symmetry. So the vertex is an xy coordinate. You get the x value from using this. So again, the x value is on the axis of symmetry. And then we find the y value by plugging that x value into our original function and seeing what y value comes out. That's how we get that xy coordinate. Let's go and take a look at an example for this, and we'll show you what it's going to look like. So here we have this function here in standard form, y equals x squared minus 8x plus c. And with this, let me get something to draw with, maybe. Bear with me a moment here. Scribble, that might work. Okay. So we have y equals 2x squared minus 8x plus 6 really quickly here. A in this case is equal to 2. B is equal to -8 because it's a -8. And C in this case is 6. Now if you recall from the slide we were talking about a moment ago, the C value, that is our y-intercept. this is going to cross our y-axis at 6. So let's go ahead. I'm going to actually change my line color here so we can see it a little bit better. Let's turn it to red. We're going to have a point on our y-axis at 6, right there. There we go. There's that point. Good. Okay. So that's one point we have on here. I'd like to start with kind of the easiest part. Let's find where our axis of symmetry is. So our axis of symmetry, if you recall, is found at x equals negative b over 2a. And so in this particular case, b, as we said, is negative 8. So it's going to be negative 8 over 2 times a. But a in this case is 2. So negative 8 is 8. Divided by 2 times 2 is 4. We have the vertical line, x equals 2. Again, this line doesn't actually exist on here. It's just here to help us. Let's make this a little bit thicker. 2 points should be fine. Okay, good. This is just to help us graph, but we have a vertical line here. Again, that vertical line is our axis of symmetry. So that means anything on. And we'll talk about that more in just a little bit here. Now the other part that's nice about this here, x equals 2, that is the x-coordinate of our vertex. Oops, let me go back just a little bit here. This is the x value of our vertex. We need to find out what the y value is, though. We need to find out where that vertex actually is. So we take x equals 2, we're going to plug that into our function and see what comes out. So when x equals 2, y is equal to, let me back that up there. So y equals 2 times 2 squared plus 8x plus 6. So I'm running out of room here. And again, instead of x, this is supposed to be a 2. That's my mistake. Okay, so 2 squared is 4 times 2 is 8. And then minus 8 times 2. 8 times 2 is 16 plus 6. Negative 8 plus 16 is going to give us negative 8 minus 16 is negative 8 plus 6 is negative 2. So when x goes in as 2, y comes out as negative 2. We have the coordinate 2, negative 2 as our vertex. So 2, negative 2, boom. Right there is our vertex. All right, so now we just have to do a couple things to finish this off. One thing that we need to do is we need to get a few more points. I'd like to have 5 points on here if possible. So using my axis of symmetry, if I have the coordinate 0, 6 on here, well, it means we're also going to have a point on the other side in the same spot. So notice how, so this point is 2 away from the axis. This point is also 2 away from our axis of symmetry. So let's go ahead. All right, looking pretty good. I'd say we'll find one more point. Let's see what's happening when x is equal to 1. Again, you can take any x value, plug it in, and see what y value comes out. And I'm running out of space here, but when I take x equals 1, and I plug that into our original function, 1 squared is 1, 2 times 1 is 2, minus 8 times 1 is 8, plus 6. Negative 2, or 2 minus 8 is negative 6, plus 6 is 0. So that means we have the coordinate 1, 0 on here. So we have a point right here. And then again, using our axis of symmetry, we'll also have the coordinate 3, 0 on here as well. And from here, what we should do is you should draw a nice kind of curvy bowl shape. Again, parabola makes kind of a U. Do not draw straight lines between these. It makes kind of a U. I apologize, this is off a little bit. It makes this U shape from this. So again, we had our vertex here at the coordinate 2, negative 2. We had our, and again, this vertical line x equals 2, which matches this right here. That's our axis of symmetry. And then also we have our y-intercept, which was 6. Now, let me just make a few comments on here. In the slide here, we talked about A telling us if the parabola opens up or down or is wide or narrow. I'm going to take this moment to describe A a little bit for you here, and we'll try and tell you a little bit more about it. In this particular case, our A value was 2. It was a positive 2. A was positive 2. So with A being positive, when A is, I need to make that. when a is positive, when a is positive, then it's actually going to be, we say that it opens up, makes this bowl shape. When a is positive, it opens up. When it's negative, on the other hand, when a is negative, it's going to flip it over, it's going to open down. That's one thing that the a value does. So again, when a is positive, it opens up like we have here. When it's negative, it opens down and makes more of like an umbrella shape. There's one other thing that a does. I'm going to have to erase a few things here in order to be able to do that. So give me just a second. I'm going to take this stuff away for now. The other thing that a does is when a, and I'm going to write this very technically, but I'll describe what it means. When a is, I should say that when the absolute value of a is larger than 1. So these are numbers like 2, like we had here, like 3. Remember, absolute value means distance away from 0. Anything that's larger than 1, as well as all the negatives that are smaller than negative 1. So that'd be numbers like negative 12, negative 4, negative 8. Any numbers that are, again, the absolute value is greater than 1, those make our graph compared to our parent function, which again we saw in this slide right here, our parent function. Any functions like that, we actually would say that they are, any a values like this, we would say that they are narrower than our parent function. They're narrower than our parent function. Which now, the other idea is when the absolute value of a is less than 1. When the absolute value of a is less than 1, so these are like your decimals, so this would be like 0.2, that'd be like 0.3, negative 0.7, or even your fractions. Again, these values have to be smaller than 1, so like 1/2, 2/3, negative 3/17. All of these values, when we get like these fractions, the decimals, they make the graph wider. So that's a bit of a description of what a is. I'd recommend taking notes on something like this, but that's how we graph using standard form. Now, there are a couple of other forms that we're going to need to talk about today as well. The next form that we're going to talk about is called vertex form. It looks like this: y equals a times x minus h squared plus k. Again, the a works exactly the way that it did before. It tells us if the parabola opens up or down, or if it's wide or narrow. And the special thing about vertex form is that we find our vertex at the coordinate hk, and our axis of symmetry is also found at x equals h. Remember, our vertex is always on our axis of symmetry. Let's show you how we graph this. This is a little counterintuitive sometimes, so let me show you how it's going to look. We have y equals negative 0.5 times x plus 3 squared plus 4. Now remember, this form, this is called vertex form. So our vertex is going to be found, again, at the coordinate h. Okay, and I'm going to have to change this just a little bit again. Line color, we'll make it blue this time and bump up that. Okay, good. All right, so notice how it's x minus h. And then we find hk. So it's whatever we're subtracting from x, that is our h value. So as you look at this, you might see, okay, well, it's x plus 3 squared plus 4. Well, and if I ask you the question, well, what are we subtracting from x? Well, we're not subtracting anything from x. But we could rewrite this as a subtraction problem. Remember, subtracting and negative is the same as adding. So I could rewrite this as x minus negative 3, and it means the same thing. X minus negative 3 is the same as x plus 3. So I'm writing down my h and k. What is my h value? A lot of people make the mistake and say that your h value is 3. No, it's negative 3. You have to do the opposite of what you see in there. And then what is our k value? That works the way you think it should. It's 4. So our vertex is actually at the coordinate negative 3, 4, which is going to be found right here. There's the vertex of our function. If we found a vertex, that also means we found our axis of symmetry, because our vertex always lies on our axis of symmetry. Now from here, what we need to do is we need to flesh it out a little bit. We need to pick a couple points and see where they're going to show up, and so we can flesh this out a little bit. Even though this form doesn't tell us the y-intercept, we can still find the y-intercept in the same way that we did before. The y-intercept, again, is when the x value equals 0. So let's see what happens when x equals 0. Y equals negative 0.5 times 0 plus 3 squared plus 4. Well, 0 plus 3 is 3, squared is 9. So we have negative 0.5 times 9 plus 4. I'll write this as negative 4.5 by taking negative 0.5 times 9 plus 4. And no, I'm running out of space, but this is going to equal negative 0.5. So that means we also have that when x is 0, we get this out for y. 0, negative 0.5 is another coordinate we have. So that's going to be right around in here. It's not a nice little grid mark, but that's okay. We can still make it work. Now, using that axis of symmetry, if we have this coordinate here, which is 3 away from our axis of symmetry, it means we're also going to have a coordinate on the other side in the same spot, 3 away from the axis of symmetry. So this is at the coordinate 0, negative 1. Negative 0.5. Well, we're also going to have the coordinate negative 6, negative 0.5. I'd say we should probably get one more of these in here. I'd either test negative 2 or negative 1, see what happens. So what happens when x is equal to negative 1. So we have y equals negative 0.5 times negative 1 plus 3, and I am squared, plus 4, and I'm running a little bit out of room here, but negative 1 plus 3 is 2. 2 squared is 4. So y is equal to negative 0.5 times 2 plus 4. Negative 0.5 times 2 is going to be negative 1. Negative 1 plus 4 is 3. So when negative 1 goes in, 3 comes out. So negative 1, 3, and I think I did a mistake here somewhere. 2 squared is 4. Okay, here's my mistake. Let's back this up just a little bit here. I did my steps just a little bit out of order. Nope, still don't want to do that. There we go. Here's my mistake. Y equals negative 0.5 times, so negative 1 plus 3 is 2. 2 squared is 4. So we have y, let me get my scroll back. Y equals negative 0.5 times 4 plus 4. And that's going to be negative 0.5 times 4 is now going to be negative 2 plus 4. And negative 2 plus 4 is 2. So it means when negative 1 goes in, 2 comes out of our function. Negative 1, 2. That's much more reasonable. And I need to undo that. Now, again, using our axis of symmetry, we're also going to have, so this is 2 away from our axis of symmetry. So we're also going to have this point here. It's going to make a little bit of a bowl shape like this. Again, our a value in this particular case, what it did is our a value made, it was negative, so it flipped. So we have, it would say it opens down, as well as it was 0.5, so this is technically a little bit wider than the parent function. It's a little bit hard to tell with the way I've drawn it, but it is wider than the parent function. Alright, so that's how we graph using vertex form. The last form we need to use is going to, we call intercept form, which is right here. Intercept form, y equals a times x minus p times x minus q. A, again, has the same job. It'll tell us if the parabola opens up or down, or if it's going to be wide or narrow. And you're going to have x-intercepts at p and q. Again, you have to think, just like we did with h in the last one, you have to think a little counterintuitively. Notice how it's x minus p and x minus q. So it's going to be the opposites of what we see. Your axis of symmetry is directly between P and Q. In fact, if you take, so there are two ways you can find this. You might be able to just see it on the graph and count it in. Otherwise, if you take P plus Q, divide by 2, that will tell you where your axis of symmetry is. So let's go and see how we can use that. So we have y equals negative x plus 2 times x minus 4. Let me get this set up here. And I need... So again, we need to think of opposites. Remember, it's x minus p and x minus q. What are we subtracting from x here? Well, we can rewrite this as x minus negative 2, which means our p value is negative 2. Now, I kind of glazed over this really quickly before, but p and q, this is called intercept form because p and q, these are our x-intercepts. So p and q are your x-intercepts. Like that, I glazed over that real quickly here, but these are the x-intercepts, or it crosses the x-axis. So our p, in this case, is negative 2. It's supposed to be an equals sign. And q, this one works out fine because it's x minus 4, our q is 4. So we have points at, let me change my color here, we'll do the green this time. We're going to have a point at negative 2, and then one also at 4. Okay. Not bad, that's a good start. We have those points in here. Now we need to find our axis of symmetry. And like I said, we could either count it in and be like, okay, 1, 2, 3, 1, 2, 3, or we could find the average of these. Negative 2 plus 4 divided by 2. Negative 2 plus 4 is 2 over 2. Our axis of symmetry is at 1. Now, not only do we have our axis of symmetry here at 1, but that means if we have our axis of symmetry, we can also find our vertex, because our vertex is always on our axis of symmetry. So let's see what happens when x equals 1. We'll take 1, plug it into the function, and see what comes out. So y equals negative 1 plus 2 and 1 minus 4. We're in a little bit out of room here. 1 plus 2, of course, is 3. And 1 minus 4 is negative 3. So we have negative 3 times negative 3, we get 9 out. Our vertex is at the coordinate 1, 9. Right there is our vertex, right there. All right, looking good, not bad. I think at this point, the last thing that we need to do, the last thing we need to follow up with is we need to find one more point so we get a good idea of what this graph is going to look like. And I don't want to select all of that. I just want to select like that. Nope. All right, so let's find one more point. Let's find what's happening on our y-intercept. What's happening on the y-axis. So again, I'm going to take, let's get a different color here. Bear with me a moment here. Yeah, this one. Let's find out what happens when x equals 0. So y equals negative 0 plus 2 times 0 minus 4. Well, 0 plus 2 is 2. 0 minus 4 is negative 4. Negative 2 times negative 4 is 8. That means we have the coordinate 0, 8 on here. It's going to be this point right here. Using our axis of symmetry means we also have the coordinate 2, 8. So that goes on there as well. And we just nice and carefully draw a nice little... It's supposed to be bold. I apologize, my artistic skills are not very good. But the basic idea that we have here, we're going to have this kind of a U shape. Again, because our A value in this case was negative, it flipped it upside down, so it opened downward instead. But anyway, that is all I have. These are the 3 graphing techniques that we have. I wanted to put it to video so that everyone could have access to this if they needed it. So if you have any further questions, come see me. I'd be glad to help out. Otherwise, I hope this was beneficial for you. Thank you.